All right, I'm just going to explain verbally here your answers to your practice quiz. Remember, when it's in standard form for a circle, we just do the opposite and take the square root. So it's 3, -8 for the center, and the radius is 9, the square root of 81. To write an equation with the circle, with center 3, -3, and radius 8, again, we do the opposite and opposite. So we have x minus 3 quantity squared plus y plus 3 quantity squared. Those are both the opposites. And then the radius squared. So 8 squared is 64. To graph the circle, again, we get the center from the left side of the equation, opposite, opposite. So that's 1, -1 for the center. Take the square root of the right side. That is 1. So we plot the center, 1, -1, and count out 1 in each direction, northeast, southwest, and then draw our circle. Number 4, complete the square. Now we get all the x's and y's to one side, constant on the other. Okay, and we group our x's together and our y's together. So when we do that, we get this, and we have our plus blank. Remember that plus blank here is always going to be 1/2 of b squared. Half of -2 is -1 squared is 1. Half of 6 is 3 squared is 9. So we added 10 to the left side, let's add 10 to the right side. Now I have an error here because you get -12 plus 10 is -2. You can't ever have a negative answer here. So I shouldn't have had a -12 there. So that's an error. You won't have that on your quiz itself. So that's why it's an error for the radius. We can't find that because it's negative. But we can do the center, opposite, opposite. So 1 and -3 for our center. Don't forget this number here is always half of b. So half of -2, -1. Half of +6, +3. Okay. All right, number 5, write the rule for translation or transformation. Okay, so here all we have is a translation, went 1 to the right. It did not go up or down for the y. So remember, it always starts x comma y, arrow, parentheses, you want 1 to the right, so it's x plus 1. It's 1 to the right. Y did not change, just comma y. Over here, what we have, remember, here's the pre-image. This is the image. We got to always go from the pre-image to the image. So a common error students will make is they just pick one or the other and go to the other direction. So they start at the pre-image and go back to their pre-image, and thus they have the wrong signs here and here. So I take any two corresponding points, A to A prime. How do I get there? I go back 1, 2, 3. That's why it's left 3. And down 1, 2, 3, 4. That's why it's y minus 4. Remember, it always has to start out x comma y, arrow, and then this. Number 7, graph the preimage and the image point. So we graph the preimage point to -1, and it says to go right 3, down 3. Write it. Right 3, down 3. Count. Right 3, down 3. A prime. Very simple. Number 8, we have a triangle here. Plot the triangle. ABC right here. And then it says reflected over the line y equals 2. Remember, y equals 2 is a horizontal line. Y equals 2 right there. And now we just count. Same number. 1 there, so it's got to go 1 there. So that's A prime. 1, 2, 3, 4. 1, 2, 3, 4. Took us 1 off the board right there for B prime. And C, 1, 2, 3. So we go 1, 2, 3, and there's C prime. Reconnect them. Okay, just a side note, remember, since there's a single reflection, it's going to switch orientation. Remember, here we have ABC is clockwise, and then A prime, B prime, C prime is counterclockwise. Anytime you just have a single and odd number reflection, so it's either a single reflection or a glide reflection, it will switch orientation. So we can see that right there. You don't need to know that to do the problem, but just to verify that you put those points in the right spot, you can see it better switch orientation. All right, so we write a translation rule to go from point Z to point U. Here's Z, here's U. So I go right 5 and down 1. So remember, it always starts x comma y, arrow. I went right 5, so it's x plus 5, and down 1 comma y minus 1. And last one, rotate 270 degrees. 270 degrees, remember, 90, 180, 270. Well, it's the same thing as going -90 degrees. -90 degrees. I went 90 degrees here. We have an error here. So I went 90. It should have been -90. So that should have not been negative yx. It should have been y negative x. right there. Let me write that in there, and we'll correct it right now. X comma y, arrow y, negative x. Okay, I forgot. Oh, sorry, I did not. This says 270 degrees clockwise. Clockwise. That's actually negative 270 degrees. Negative 90, negative 180, negative 270. So that's the same as going positive 90 degrees, which is what this is. This is the positive 90 degrees, and that's what I have right there. Positive 90 degrees counterclockwise. Because this, they told you clockwise. I told you this is how they're going to write it in the park or the decast. They'll not use the negative sign for negative 270. They'll say 270 degrees clockwise. That means negative 270. Okay, which is the same as positive 90 degrees. Okay, and so we have that right there. Negative yx. Remember I told you to memorize that one. Memorize the negative 90 degree one, which would be this one right here. Y negative x will be negative 90 degrees. 180 is just negative x comma negative y. Just put the negatives on both the x and the y for 180 degrees. That goes from quadrant 1 to 3 or 2 to 4 or vice versa. Memorize the ones for y over the line y equals x, which means just to switch the x and the y coordinates, and also memorize it for y equals negative x, this one, and that's just negative y comma negative x. Switch the x and the y's and put negatives on both of them, or opposites on both of them. Okay, so since I've already typed it there, I'll say that equals rotation of negative 90. Okay, since that's what that is right there. I'll just leave it on there as a reminder for you, but we're not actually using that, so I'll move it down here. Okay, so you do have to pay attention when it says clockwise. That's telling you negative degrees. Clockwise is negative degrees, so negative 270. Okay, and backside now. So like I said, your quiz is basically going to look like this, just with different numbers and different shapes in here. Okay, and you write the new rule based off of here. The rest will be like this with just different numbers. Okay. But you should also know this because again, we'll see this kind of thing on the DCAS. I might put one of these on your test later on, or on a quiz later on, review quiz. I might just pick one of these right here. Okay, so the left one, as it says right here, the leftmost one is the preimage. Remember, we can call rigid motions isometries. They're the same thing. Make sure you remember that isometry equals rigid motion. Okay, there's no different. Now, rigid motion. Let's put a space in there. Okay, now remember, when we're talking about rigid motions, there's 4 of them. Now in this book, because I use this from one of our old books, notice it has all 4 there: reflection, rotation, translation, and glide reflection. We haven't seen the glide reflection yet. Now you're going to see it right here. So that's another reason why I wanted you to see this. So when you see a glide reflection, you'll know what it looks like. Okay, so here we go. Here's our preimage. Now obviously it's easy to see all this did was get slid down a little bit here for translation. It looks exactly like it pushed in the same direction, everything. So that's your translation. Here we can see all we do is just rotate this to get this one, so that's a rotation. Here we can see if we put like a line right here, be reflected over that line to get that one, so that's a single reflection. So by default, this is a glide reflection, but let's look at this here. You might think, oh, would that have been a rotation or something like that? Okay, well, again, if I went ahead and put points on here, for example, if I went 1, 2, 3 here, well, that's going to correspond to 1, 2, 3 here. So this 1, 2, 3 is counterclockwise. This 1, 2, 3 is clockwise. So notice it switched orientation, which means it had to be a single reflection or a glide reflection. Okay. And as I told you, if it was a singular reflection, I'd be able to take, let me erase those now. I'd be able to take two corresponding points and take the midpoint of them, that piece right there, take the midpoint, say approximately right in there. And let's say take that one in that corresponding point and take the midpoint of that right about there. And then that would, and if I connected those two, that would mean this, if it was a singular reflection, this would be able to reflect right over this, right onto here. But notice, remember, reflection has to be at 90 degrees. So this piece right here, let's say this, there's 90 degrees right there, and the same distance. That's about the same distance as that. Well, obviously the end of that arrow is not over here. It takes it 90 degrees and puts it right here. So a singular reflection would not work with that. So that means since it did switch orientation, we knew it wasn't just a singular reflection, it had to be a glide reflection. So it did a singular reflection. So this is still the reflection line. It would reflect it over to here, okay, and having it look like this down here, and then we have to translate it over to here to get it right here. So a singular reflection and a translation is what a glide reflection is. Okay, but that is how you find, take two pairs of corresponding points, take the midpoint of each and connect those, and that is your reflection line. Remember, another word, if you want to think of reflection line, is perpendicular bisector. We've talked about that. And remember, the perpendicular bisector theorem says that any point on the perpendicular bisector is equidistant from the endpoints of the segment. That is always a BCAS question, just so you know that. It'll ask you that, what the definition of perpendicular bisector is, or what's an example of it in an actual problem. Okay, so you know you're going to have, I'm just telling you, you're going to have perpendicular bisector. All right, so there's an example of how you can see where glide reflection comes in and how you can tell from that that it wasn't a single reflection. Okay, it didn't reflect directly over to it. All right, so here we do the same thing here. Okay, for our translation, that's the easiest one to see. It looks exactly like this, just slid. See, here it is right here. Exactly the same thing. Okay, reflection switches orientation. So I could put a reflection line like right here, and this would all reflect to this right here. Rotation. Okay, so if I rotated this around, I just took this and rotated it around, I would get this shape right here. And again, then this is our glide reflection. So it switched orientation, but it wouldn't just singly reflect over. Okay, so if we looked at our A, this, see, it looks just like this, right? Same orientation as this, but after it had that singular reflection, then it rotated. Okay, or it would be actually, it's not going to rotate, it's actually going to be a slide or a glide translation. Okay, but that's why it has opposite orientation, but it couldn't be done from a singular reflection. I take a singular reflection and then a translation from there as well. All right, here, the nice thing about, and again, this is why I picked these problems to do, because we haven't seen these in our worksheets so far, and yet this deals with the actual definitions of translation and rotation itself. So I want to see you, show it to you visually of how it actually looks. Remember, translation, as we've talked about, is two reflections over parallel lines. Here's our example: two reflections over parallel lines, two reflections over parallel lines. So it's a translation. First, remember I told you rotation is two reflections over intersecting lines. They intersect. So therefore, this is automatically a rotation. Remember, since it's two reflections, but all these are two reflections, the preimage and the image will have the exact same orientation. Anytime it's two reflections, orientation remains the same. When it's a single reflection or three reflections for the glide reflection up here, that's when it switches the orientation. Okay, so it says you reflect over L first, and that gives you this piece, and then the M gives you this one. Okay, it's not totally accurate. This B should be a little bit further over. I just did a quick sketch of it. Just so you know, if they were to ever ask you, again, we haven't, this is not an Engaged New York, this is in our old books. Okay, if it was to come up, I can't remember if it has or not, on the DCAS. The total distance that this preimage is moved to the image is double the distance between here and here. So if that's 1 inch, let's just say that was 1 inch, The distance from here to here would be 2 inches. That's why I'm saying this is a little bit off. It should be a little further over. Okay, just as with the rotation, if I take the angle between these two lines, between these two lines, so say that was 40 degrees, then the final rotation would be double that also. It would be 80-degree rotation. Okay, so we reflect over L first, gives me that one, and then take that and reflect it over M. Okay, and it probably should be a little bit further down in here. Okay, I suppose right there, it should, remember it's got to be at 90 degrees, so that's closer to 90 degrees right about down in here. So that total rotation around that center point, that'd be the center point right there, would be 80 degrees. You would rotate that 80 degrees from there to there if it's drawn correctly. First for this reflection, and then this reflection. And so that would have been 40 degrees right there. Again, if this was now, so let's just say this was 2 centimeters from here to here, then from the pre-image here, the image would be a total of 4 centimeters, double that distance. Okay, just in case that comes up, that's we haven't seen it. It wasn't engaged in New York, but it's in our old. This is from our old geometry book here. All right, next. State where the mapping is reflection, rotation, translation, or glide reflection. Again, more practice with this. Now, I've seen this almost this problem on the DCAS right here. So this is very good, and this problem both on the DCAS. Not that they would have all these, they just choose one of these to put on the DCAS. Okay, but both of these types are on there. So that's again why I chose to copy and paste and put this into on this side of the worksheet to have you do. Even though I'm not quizzing you on it, I might do one of these, pick one of these from this drawing, for example, for your actual on your test, for example, or later on a future quiz. Okay, even though it's not going to be on this quiz. All right, so here we have ABCD right here, and you see I'm drawing this to see the orientation clockwise to GHCD. GHCD, this one right here, and notice it goes in that order, GHCD. So that's counterclockwise. So that's a single reflection or a glide reflection because it switched orientation. Well, here I can just think of this right here's my reflection line. It reflects right over to it. That's a single reflection. HGJI. HGJI. Oh, so I didn't, this one must have been using, okay, HGJI. This is actually drawn wrong. This should be HGJI like this. Okay, so counterclockwise to LMJK. LMJK. Okay, counterclockwise, counterclockwise, same orientation. Okay, and that means it's either translation or rotation. Well, obviously it's not a translation because it does not look exactly this shape, just slid down here. So it has to be a rotation. And you can see that if I take corresponding points, it goes right through the origin, and so it's a rotation of 180 degrees from quadrant 2 to quadrant 4, if you want to think of that right there with our quadrants. We'll come back to glide reflection in just a second. Translation, MNOP, clockwise, and ABCD. ABCD, clockwise, same orientation. So it's either rotation or translation. Well, you can see it, MNOP right here. This is the exact same shape as this. All it did was slide right over here. So translation. So obviously, well, it's not obviously because they could have had a repeat here. But so we look at here, GF, GFED, clockwise. Okay, RQOP, RQOP, counterclockwise. Again, notice the first thing I'm checking is the orientation. So clockwise to counterclockwise. So that's switched orientation. So that means it has to be either a single reflection or a glide reflection. Well, this is a glide reflection because we can see what happened here. This right here got reflected over this line, comes up right here like this, and then slid down here. Okay. No, okay, let's see. Oh, it's right here. RQ, yeah. Okay, so reflected here and slid down to right here. So that's my singular reflection plus a translation, and that's a glide reflection. Okay, last one, something we haven't talked about yet, so I'm going to explain it right now. Whenever I have a regular polygon, regular means all sides are equal and all angles are equal. That's the word for regular, so you need to memorize what regular means. It's also in the SAT as well, knowing that. But you're going to see that on the DCAS for sure. So regular means same side lengths and angle measures. When we say same, you can say congruent. Same or congruent, or commonly used geometry term congruent. That's what regular means. Now, whenever, and you will have that, it doesn't have to be an octagon, but a regular, some type of polygon. And you pick the center, that means all these angles right here are going to be the same. Well, how are you going to figure out it is? Okay. Um, the total degrees of all the interior angles of all these angles. Well, for these one right here, very simple. Notice it forms a circle, right? Where I put all these angles together, it's a circle. So 360 divided by 8, octagon is 8, 360 divided by 8 is 45 degrees. So each of these is 45 degrees. So each is a 45-degree rotation when I go from one point to the next. Because remember, I could have actually drawn a circle. Let's see where the circle is right here. I could have constructed a circle and it would go through all of those if it was perfectly done right. Or some of this drawing's a little bit off. Okay, but it's pretty close to going through all of those. Okay, but that means this drawing's a little bit off. But they told you, remember, words count over the drawing itself. Okay. So just so you know, another piece to go along with that before getting back to this problem. If I want to rotate, if they had a point out here in the center of rotation right here, it says rotate it 45 degrees, I would take, and it said, how would the construction be? Because you're going to have a problem like this on your unit test at the end of the module here. That's what I'm telling you right now. You construct a circle from the center of rotation through that point that they want rotated, creates a circle, and then you rotate that point 45 or however many degrees they want along that circle. Because remember, from the center, all these would be radii, the same equal distance out to the center or out to the circle itself. So you're going to rotate that however many degrees they want. But you start by constructing a circle with the center, with your pointer at the center of rotation, pencil out here on the point you're rotating. Okay. So that's a question, like I said, that's on the module exam. All right, so back to here now. So it says, what point will you end up on if you do 45-degree rotation about G, of G, sorry, about Z. About is what you're rotating about. Notice it's about Z every time, the center of rotation. So 45 degrees, remember, that's positive, isn't counterclockwise. 45 degrees is only one rotation. So G goes to I. There's my answer. 225-degree rotation of U. I could go 225 degrees, or 360 minus 225 is 135. So there's 45, 90, 135 negative degrees. Same thing. I. 315-degree rotation of E. So find E. 315 degrees, what's the same thing as negative 45? 360 minus 315 is negative 45. That's one rotation this way. I again. 270-degree rotation of segment EI. There's EI. I want 270 degrees. What's the same as negative 90, right? So it's negative 45, negative 90. So E goes to G, and then I, negative 45, negative 90. So we get GH, segment GH. You got to have the segment bar above it. 135-degree rotation of S. Here's S, 135 degrees. Again, positive degrees, counterclockwise. So there's 45, 90, 135, G. And 360-degree rotation means we're obviously right back onto itself. Of ST is going to give you ST itself. Okay, and there's your answer. All right, that will answer all these questions. Like I said, the front page is what your quiz is going to be on, but several of these you might see, or not several, but maybe two of these you might also see this type asking a question related to this on the decast as well. That's why we need to know this side as well. All right, have fun.